The Strait of Gibraltar, the dream of connecting two continents. The Strait of Gibraltar is a narrow stretch of sea separating Europe and Africa. This place has long inspired a grand vision, a bridge or tunnel connecting the two continents. Today, we'll explore this fascinating idea. Grab a cup of coffee, and let's dive in. First, let's examine the location and distances involved. The Strait of Gibraltar connects the Atlantic Ocean to the Mediterranean Sea. Its total length is about 60 kilometers. The width varies from 14 to 44 kilometers. Clearly, 44 kilometers is excessive. There's no point building a bridge that long when shorter options exist. The narrowest section, where Spain and Morocco are just 13 to 14 kilometers apart, is much more realistic. To put it in perspective, that's about a 13-minute car ride, which is practically nothing. People realized this potential a long time ago. In 1979, Spain and Morocco set up a joint committee to study the feasibility of connecting the continents. This led to a broader initiative under the Euromed Transport project. Since 1981, Spain has funded a corporation tasked with researching and promoting this connection. But the idea of a bridge and its potential usefulness has been around much longer than these committees and projects. Yet despite all the discussions, there's still no bridge or underwater tunnel. So, what's the holdup? Is it technical issues? Not at all. Humanity already has the technology to build such a structure. Let's break it down. A bridge across the Strait of Gibraltar would need to be about 14 kilometers long. For modern engineering, that's not particularly daunting. There are already longer bridges in the world. For instance, the Chesapeake Bay Bridge Tunnel in the United States spans 24 kilometers. South Korea's Incheon Bridge is 21 kilometers long, and the Shenzhen-Zhongshan Link in China, a colossal 24-kilometer project, combines a 17-kilometer bridge, 2 artificial islands, and a 6.8-kilometer underwater tunnel. Then there's the Lake Pontchartrain Causeway in the U.S., the longest water bridge globally, stretching 38.5 kilometers. In comparison, a 14-kilometer bridge across Gibraltar sounds feasible. Engineers agree. There's even a detailed plan, deep foundations, towers rising 910 meters high, and spans of 5,000 meters. The estimated cost? Around $15 billion. That's not unreasonable for a project connecting Africa, home to 1.5 billion people, with southern Europe, population 150 million. This bridge would see heavy use. Studies confirm its economic, social, and safety benefits. Reducing reliance on sea transport would greatly enhance trade efficiency. Bad weather can disrupt shipping, but it wouldn't stop a bridge. The benefits for trade and tourism are enormous. A bridge could also help regulate migration, offering safer and more controlled routes. Plus, it would create tens of thousands of jobs during construction and operation. So, why hasn't this bridge been built yet? There are several reasons, mostly tied to the strait's geography. The strong currents and tidal flows in the Strait of Gibraltar are formidable. The narrower the strait, the stronger the currents, creating an unpredictable environment. Even ships passing through need to proceed cautiously. Factors like rapid water evaporation, varying salinity, and water density layers add complexity. For instance, less salty Atlantic water flows eastward at the surface, forming a layer about 125 meters deep, moving at 4 to 5 kilometers per hour. Beneath it, denser, saltier, colder water flows westward into the Atlantic. These opposing flows generate internal waves that can shift up to 100 meters vertically and stretch 2 to 4 kilometers long. Fun fact: astronauts can see these waves from space. Building a bridge in such conditions is a major challenge. Then there's the issue of marine traffic. The Strait of Gibraltar is one of the busiest maritime routes in the world. Every 5 minutes, a large ship passes through, not to mention countless smaller vessels and yachts. Blocking the strait during construction would disrupt global trade. Alternative routes exist, but they are slower and more expensive. Building a bridge while accommodating this constant traffic is nearly impossible. Moreover, the bridge would need to be tall enough to allow the largest ships to pass underneath. For context, the world's biggest container ship, the MSC Oscar, is 400 meters long and 60 meters wide. Its height, including the part underwater, reaches up to 70 to 80 meters. A bridge tall enough for such vessels would be a monumental engineering feat. Even then, the risk of ship collisions with bridge supports remains high, requiring robust measures to ensure safety. And what about a tunnel? A tunnel is another option, but it has its own hurdles. The Strait of Gibraltar lies at the boundary of two tectonic plates, the African and Eurasian plates, making it prone to earthquakes. Just recently, 183 earthquakes were recorded in the Mediterranean in a single day. Most were minor, but they're still a concern for infrastructure. Southern Spain near the strait is a high-risk earthquake zone. Morocco has its risks too. In 1960, near Agadir, an earthquake of magnitude 5.8 struck, causing massive destruction. It killed about 15,000 people and left 35,000 homeless. Such tectonic activity makes the region less than ideal for large-scale construction. And then there's the seabed. If you drain the strait, you'd reveal a chaotic landscape of valleys, ridges, and mud volcanoes, shaped by water flow and tectonics. Building here is an engineering nightmare. In the 1930s, tunnel plans were scrapped because the seabed rock was too hard to drill. The narrowest point of the strait is also its deepest, 900 meters. For comparison, the deepest underwater tunnel today, Norway's Ryfast, is only 292 meters deep. Gibraltar's depth makes tunneling at its narrowest point nearly impossible. What about environmental concerns? The Strait of Gibraltar is not just a key trade route, but also a critical ecological zone. It's a meeting point for marine life, including whales, dolphins, and migratory birds. Any large-scale construction risks disrupting this delicate ecosystem. Increased noise, pollution, and changes to water flow could have long-term impacts on wildlife. Modern projects must carefully assess and minimize these environmental consequences, but even with mitigation, some damage is inevitable. Still, the tunnel idea isn't dead. In December 2003, Spain and Morocco agreed to explore a rail tunnel under the strait, linking their rail networks. Sound familiar? It's like the Channel Tunnel between France and the UK. But unlike the stable English Channel, Gibraltar's tectonics and hydrology are much more challenging. After years of inactivity, the project was revived in February 2023. Construction is now planned to start in 2030. The tunnel's underwater section would span 28 kilometers at a depth of 475 meters, with construction expected to take 15 years. Why 28 kilometers instead of 14? Engineers abandoned the narrowest point because of its extreme depth. Instead, the tunnel would connect Punta Paloma in Spain to Cape Malabata in Morocco, avoiding the deepest areas. The estimated cost is $8.8 billion. The tunnel could carry 12.8 million passengers annually and transport 13 million tons of cargo. If completed, it would reduce travel time between Madrid and Casablanca to just 5.5 hours by train. A few extra thoughts. British researchers have used mathematical modeling to explore new bridge designs, looking for the ideal structure to connect Europe and Africa. The most promising designs resemble bicycle wheel spokes rather than traditional tower and cable setups. While theoretical, these ideas might make future construction easier. Lastly, scientists predict that tectonic shifts could eventually close the Strait of Gibraltar. Researchers from Lisbon University suggest that plate movements could create a new ring of fire with active volcanoes. But don't worry, this won't happen for another 20 million years. By then, no one will care about bridges, tunnels, or trade routes. So, what do you think? Should we build a bridge, dig a tunnel, or leave things as they are? Let us know in the comments, and don't forget to like, subscribe, and share. Until next time.